Hi everyone, this is your math guru. In this video, I'm going to show you how to find all the missing angles of the following right angle triangle using trigonometric ratios. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. The acronym for the trig ratios to use will be SOHCAHTOA. So I have my SO, CA, and TOA. What this means is, for the first one, sine theta or sine of the angle equals opposite over hypotenuse. For cos, we have cos theta or cos of the angle equals adjacent over hypotenuse, and your tan of the angle equals opposite over adjacent. To determine the trig ratio to use, I'm going to start by tagging all the sides of my triangle based on the reference angle. So for example, in the triangle given, I have triangle ABC with sides AB 21 units, side BC 20 units, and side AC 29 units. If I make the angle at A my reference angle, that means this line or the side facing my reference angle will be called my opposite angle. The side facing the right angle, or the longest side, is called the hypotenuse. And a triangle has three sides. The last side, not labeled, will be your adjacent. The hypotenuse is always constant. That is the side that is always facing your right angle. However, the adjacent and the opposite can change or is being determined by the reference angle. So always remember that the reference angle, the line facing the reference angle, will be your opposite as shown. So therefore, to determine the trig ratio to use, I'm using A as the reference angle. I can see that I have adjacent, opposite, and hypotenuse. All the values are given, so I can use any of the trig ratios. For this example, I'm going to use sine, such that my sine A is equal to, from the acronym, sine is SO, and that means opposite all over my hypotenuse. If I go back to the diagram, the opposite value will be, I have sine A equals opposite, that's 20, as tagged, and the hypotenuse is 29. To find A, I'm going to move my sine to the right hand side, and that will become my arc sine of 20 over 29. And if you punch that in on your calculator to find the arc sine, it's usually the second function of your sine button. You have angle A equals arc sine of 20 over 29 will give us 43.60 degrees. Don't forget to put your unit. We're finding angles, and this is in degrees. To find the remaining angle, we know that a right angle, that's angle at B, is equal to 90 degrees. All the sum of angles in a triangle add up to 180. So I have angle A plus angle B plus angle C equals 180 degrees. The reason being, sum of angles in a triangle ABC add up to 180. Angle A, as I calculated, is 43.60 plus angle B has been given as 90 degrees plus angle C equals 180 degrees. If I add 43.6 plus 90 degrees, that will give me 133 degrees, 0.6 plus angle C equals 180 degrees. Using the balance method, I'm going to subtract 133.6 from both sides. I'm left with angle C equals 180 degrees minus 133.6 degrees. Therefore, angle C is equal to 46.4 degrees. So, by our calculation, we've been able to find angle A, which is 43.6, angle C, 46.4, and angle B, as given in the diagram, that's 90 degrees. Let's look at the second example. In my second example, I have the triangle given ABC, so that line AB is 16, line AC 34, and line CB is 30. Using my trig ratio, the acronym is, I have my SOHCAHTOA, sine opposite over hypotenuse, cos adjacent over hypotenuse, and my tan of the angle equals opposite over adjacent. In this example, in the last example, A was my reference angle. In this example, I'm going to make C my reference angle. So once I can find my reference angle, I'm going to tag all the sides of the triangle, starting with the side facing the reference angle, which will be the opposite. Also, the side facing the 90 degrees, or the longest side, is your hypotenuse, and the third side will be your adjacent. Remember, like I said earlier, the opposite and adjacent changes based on your reference angle. Always remember the side facing your reference angle is your opposite. The hypotenuse is constant, is always the longest side or the side facing your right angle. So in this example, because C is my reference angle, this time around I'm going to use my cos as the trig ratio to use. So I have cos C equals, cos is adjacent over hypotenuse, so I have that as adjacent over hypotenuse. I have cos of angle C equals, adjacent is 30 and hypotenuse is 34. To find C, I'm going to move my cos to my right hand side. It becomes arc cos of 30 divided by 34. Therefore, the value of C, the arc cos, is the second function of your cos button on your calculator, and that will give you 28.07 degrees. To find the remaining angle, so I have that as 28.07, I can either use any of the trig ratio again, making A as my reference angle, or better still, I use the sum of angles in the triangle. Sum of angles in the triangle, angle A plus angle B plus angle C is equal to 180 degrees. The reason being, angles in a triangle ABC add up to 180. I have angle A missing, that's the last angle, plus angle B has been given as 90 degrees, plus angle C, 28.07 degrees, equals to 180 degrees. If I add that together, I have A plus 90 plus 28.07. I have that as 118.07 degrees equals 180. Subtracting 118.07 from both sides, I have angle A equals 180 degrees minus 118.07 degrees. Therefore, my angle A will be equal to 61.93 degrees. So my three angles, I have angle C, 28.07, angle A, 61.93, and angle B, as given in the diagram, 90 degrees. Thanks for watching. Bye.